Hello, hello. Welcome to the Grafana Agent Community Call on May the 18th. And today we got a few topics. We have one topic. And we are going to be digging into a review of the Agent Flow PR that Robert kicked off. So, unless anyone has any questions to bring up before that, all right. And we will jump into Robert, if you want to take the lead.
Sure. So last month we kind of talked about agent flow in general and talked about kind of like the two main approaches we were thinking of exploring. One being like an actor model where different actors are different components and they can interact with each other by sending messages. And the other one being like more of like a declarative actor model, kind of, where we use HCL and expressions to bind components together like through their values. We prototyped both of those approaches internally and kind of agreed to focus on the HCL based approach for now. That doesn't mean like, what we want to do is pick one, ship it like an MVP, and then get feedback, and then figure out, is this the right approach, or should we try actors again, or should we like try something else entirely? Should we do nothing? Always a good choice. But for now, we decided to at least focus our efforts on the HCL aspect. So part of the MVP is going to be focused around metric-based components. And the first part of that is kind of finalizing the controller, which kind of runs the HCL graph and kind of manages all the components that are running. So we have a PR that I opened for that and for the initial controller, which I'm going to screen share, and we can just kind of do like a live code review of what we have and maybe get some feedback so we can fix it before it gets merged. Just give me one moment. Actually, here's what I'll start. I'll start with showing the PR description because I think that might be useful. All right. And close Google Drive. Okay, so controller is a weird term, I think. Like, it's kind of hard to say what a controller is. I know, like in Kubernetes, the control plane is the idea of having like a suite of things, which I'm trying to explain it. I actually don't know. Like, I don't know what a controller is. I think you can kind of intuit what a controller might mean, but in this context, the flow controller is the thing that loads HCL files, populates a DAG, and like runs components and updates them whenever they change. So at like the lowest level, a component is going to be like an individual unit of business logic. For example, getting something out of Vault would be a component, or scraping Prometheus metrics from a target, that would be a component. And each component has a set of input arguments, and it can optionally export like fields that other components could use. So an input argument for like the Vault example would be like your Vault key. And then the optional exported field would be the value of that Vault key that got retrieved. Not all components will export something. So like something doing remote write probably wouldn't export things for other components to use, but components that do have something to export, can do that. The exports can change over the process's lifetime. So again, with the Vault thing, maybe it refreshes every 10 seconds, for example. And then if the output or the Vault value of that key changes, its exports will be updated to the current state of the value whenever you do a refresh. And any component which is referencing that, did I hit reject or did I hit accept on that person's writing?
I hit accept.
Okay, there you go. There it goes. And then any component which is referencing the output of the Vault key would then be updated to reflect the current state of things. So that's a high level what a component is. So then to specify a component, like I said, we're using HCL here. So I shouldn't have used the ball example because all the documentation here is using remote HTTP. But imagine a component which can like do an HTTP request, and then its exported field is the like the response body of that request. So this might be how you configure that component. Like, it's in the remote group. The type of remote is HTTP, and you can give it like a user identified name here. I'm just calling a get URL just arbitrarily. So every 10 seconds, we get this URL, and then it would export, for example, like a response body field. So another component, another remote HTTP component, could use the response body as its input for the URL. It's a really contrived, bizarre example. In this world, I'm saying like you get a URL by making a request against another URL to get a second URL. It's weird, but hopefully this kind of like demonstrates the chaining and how you would connect components together. And the original prototype, we showed like a much more useful example of this. Let's see if I can bring that up real quick. So in the original example, we kind of had that remote HTTP, like it gives you an API key back, and then in the remote write, we bind the password to that API key. So this is like a much more realistic example of how you might use these remote components to get remote values from some store. So we could imagine like a remote vault and a remote S3, and they can be any string, and they can be used for anything that accepts a string. So one interesting point to make is that like this composes like a fully qualified identifier for a component. So we would say that there is one instance of remote HTTP get second URL running, and that name would have to be globally unique. So you couldn't have a remote HTTP, you couldn't have two remote HTTP get second URLs, but you could have one remote HTTP get second URL, then remote HTTP get another URL. Like that would allow them to be distinct. However, some components won't support this user identifier, which means there can only ever be one of them forever for the process lifetime. A good example of that would be Node Exporter, where because of actually CAdvisor would be a good one, because of how like CAdvisor was designed, you can't really run two of them in one process. So that would be one component which wouldn't have a user identifier, and in the file you would just say like Node Exporter or CAdvisor. Does that make sense to everyone?
Yep.
Okay, cool.
Yep.
So the implementation of the controller. There's kind of a few parts. There is a loader, which will, given like a set of HCL blocks, it'll construct the DAG. And it'll also evaluate components within that DAG after like it wires dependencies together. Then there's the scheduler, which given a set of components that should be running, it'll just keep them running. It'll manage Go routines for them. So as components run, they might export new states. And if that were to happen, they need to be put in a queue for later processing. So that's this queue. Matt, go ahead.
I do have a question. What do you mean by an unordered queue?
So good question. It's unordered in the dequeuing is random. Like you'll dequeue anything that got queued. It's unordered because I'm lazy.
Okay. I was
I'll show you how it got unordered, but like really all we needed was like a set of things to process later. The order didn't really matter. And so the easiest thing to do was a map. So because you can't like read from a map the same way every single time, it becomes an unordered queue. That can change over time if there's a reason it needs to be ordered, but it does mean anything that changes might not really be evaluated right away.
Gotcha.
So there'll be a Go routine which reads from the queue over time, and then as things are dequeued, they'll be reevaluated. And then anything that depends on them will be reevaluated so that like their changes propagate to things that reference them. The last part of it is the component node. So this is kind of the wrapper around an individual component within the DAG. It manages that component, and then like it exposes a different API over that component. All right, so I want to talk a little bit about HCL. HCL uses a type system called GoCTY. I said duck typed, but now that this is going on YouTube, I don't know if duck typed is actually correct, but I think it's duck typed. So when you evaluate something in HCL, you need an eval context, and that context lists all the variables which are accessible to the thing being evaluated, and all the functions which are accessible to the thing being evaluated. You can create children eval contexts from a parent, which essentially forms a tree, like a scoping tree. So for example, you could have like a root scoped eval context, which has all your functions, and then a child scope of that, which has all the values of all the components that are currently running. And that is exactly what we're doing, where we have a root eval context, which is all the functions. And then we have something called a value cache, which caches the current arguments and exports for all the components, and then builds an eval context from like the cache values. So that means when we evaluate another component, they have access to everything, any value that they might want to use from another component that was running. Does that make sense? The important bit of the cache is that you always evaluate the first component you evaluate has to have no dependencies. So you have to make sure that the dependencies are always evaluated first before you evaluate the things that depend on them. Otherwise, their values will not exist in the value cache. And that's how we like consume the DAG, figuring out what that evaluation order is. Any questions about that? Okay. Last bit. I am doing something weird and a little gross in terms of HCL, and I am using GoCTY's capsule types. So capsule is short for encapsulation, and it allows you to pass around arbitrary Go pointers over HCL. Terraform doesn't use this. None of HashiCorp stuff actually use capsule types. But I think it's really, really interesting for Flow because it does mean we can do something like in the original example where this metrics forwarder, which is a WAL and remote writes, it exports a receiver, which is a Go interface where things doing scraping can just push metrics to it. So this is sending to that receiver. It does mean there are some side effects about what you can and can't like serialize back to the user when you're showing them what the config is, but it's really, really useful for easily wiring together like complicated Go objects. The other way of doing this without capsule types would be handles. I don't really like that idea because then it means like the implementation of components has to get a little more annoying where you have to like look up what a handle is and get the actual value. So being able to use the capsule types like this is really convenient for developers, and for the user, values or handles either way, it doesn't really matter to them. That detail would be abstracted in both cases. So there's a lot we haven't done with the controller. This PR, like it's not being used anywhere. I'm just showing you as a base example. This used to include like log level and long format, which wasn't used. That got removed. So this needs to be removed as a like future thing. But we do need logging. Like we have logging, but we need to be able to specify what the log level is at the file. Also, this doesn't have TLS settings for the server, which we'll do that later. Also, it doesn't detect reference cycles, which are invalid. Eventually, we'll add cycle detection and prevent those files from being loaded. This also doesn't come with any components other than like test components, which I built for testing. Also, there can only be one HCL file. At some point, we might want multiple file support, like modules or whatever, like includes. We don't have those yet. Then this is also no longer true, but I'll explain that later. Okay, that was me reading the PR description. So let's start with questions before I go into any code. Pascalis?
I think that we can use the actual implementation to build some test components and get a feel for this PR, right?
Yeah, but I also think if this PR gets merged, like I don't think. Well, I guess that's up for discussion. But I personally don't think this needs to wait. Unless there's like a really big issue with it, like we can just iterate over time, and like if this was merged, we could build components now.
No, totally agree. But if someone wants to like get a better feel for it, other than the code, it might be a good idea.
Yeah, like our tests use the test components, and you can add a new. You can use those in tests if you want to play around with it. That's totally true. All right. Any other questions? I'm going to take a drink of water, and then I'm going to share them. Sorry to Emacs users. Okay. All right. I'm going to start with the component package because this goes over some details. A lot of this I kind of already described. In terms of like, components have arguments and exports. So I'm just re-describing here in a lot more detail. I'm also requesting for now that there are some reserved fields. We don't actually check for this. It's not being validated here. But at a documentation level, we're suggesting that these are reserved, and if you try using them, it'll eventually be rejected. So for each is something that Terraform uses for like dynamic components. I suspect will also have the same thing at some point. Enabled to like, this is like the equivalent of count with Terraform. For us, count doesn't make sense, but enabled would. If we have that eventually, it's reserved for now. And then health and debug, these are fields which will be exposed to the user when they ask for like the config being marshaled. They'll say what the health is and what debug info is, so you can't use those. Pascalis?
Can you zoom in a level or two? Thanks. Sorry.
No problem. All right, so some other things. When you're implementing the struct for encoding and decoding, the struct for arguments and exports, any of the values can implement encoding text marshaller and encoding text unmarshaller. That means, for example, like you don't have to validate if a log level is correct, because the log level can implement this interface, and you can just force that like the strings are a correct value. And for example, if it was log level and the only valid log levels were info, error, whatever, those, and you put in foobar, you'd get back an HCL error saying like foobar is not valid, and then you get the line number in your HCL and like where exactly that's wrong. And if you wanted to implement a capsule type, you would have to call register go struct. The capsule types have to be structs; they can't be interfaces, but it can be a struct that contains an interface. So that like effectively is mostly the same thing. You just have to wrap it. Then you have to register components by calling the register method. So the interface of components are really minimal. They just have to run, which is guaranteed to be called if the component was built correctly. It's guaranteed to be called exactly once per component. So if you need to do cleanup, you do it on the defer of run. And when run is called, it should not exit until at least there's an error or context gets canceled, like a fatal error. Then update would be called anytime the inputs or the arguments for the component gets reevaluated, and you would be given the new set of arguments, and you should change your state to match what those are. Also, components can implement the health component interface. So this is if they have health information to export. So if they do have the health information, this might be called whenever the user is requesting health for components, or like if we have like a metrics exporter which shows health, whatever. It might be called at any time. It might be called asynchronously, multiple go routines. It should be go routine safe. The health struct is a tuple of state, a message, and when that health was generated. So for example, if you load like an invalid file, it'll get marked as unhealthy with the message being like what the error was in the file, and then the update time will be the time you try to load that file. But then components can have whatever health they want. So the health types are unknown. This is like the initial state, and then they can either be healthy or unhealthy, and the controller can mark them as exited if the run method exited before it should have. Any questions so far? Okay. I'm going to skip over register go struct. It's just basically what I said. You can read the documentation for that. In the registry, when you register a component, you have to give it a name, which is like remote.http or remote.vault or whatever. There's some rules here. You can read that in detail if you want. The components which have to be globally unique are called singletons. So like node exporter would be a singleton, and you would set that to true. And then you have to register what your types are. So the component for the process lifetime cannot change the underlying Go type being used for arguments and exports. So they're registered here, and then we validate when you generate exports that the type is still the same. So you can't change it. This allows us to do type checking later on, or more, well, like better type checking than we have now, which is kind of just at runtime. All right, last bit is build. This is how we build new components. So we give you a set of global options, which are things like what's your ID, and then what logger can you use, and where should you write data. Then here's the function to call if you change your exports, and then the initial set of arguments that got evaluated, and then arguments past that will be called through the update method. I think the rest of this is self-explanatory. Like, oh, right. Then this is internal. We need to build a schema for like all the components that are registered. So if you call this is used by the controller itself. Users wouldn't, like developers wouldn't really use this directly. Okay. Any questions? All right. I have an all component here. It doesn't do anything, but the idea is we would import all components that exist. And then if someone wanted everything, they could just import this package instead of all like 20 or however many we have. Excuse me. All right, moving on to the flow package itself. Okay. A lot of this I already described, but what I do want to add is the overall health of a component is merged with the health of the component at a graph level. So a component which is running could be healthy. However, it could be unhealthy from a graph perspective because we tried to reevaluate its input and something failed, or like the reevaluate input was wrong for some reason. The component itself wouldn't know that because its update method never got called. But we would know that at the graph level. So if at a graph level the node is unhealthy, we override what the component says and we'll report kind of like the graph level health. I document rules for how that merging is done in the component node struct. And then evaluating, I think I already talked about this. Like you have to evaluate things with no dependencies first before you can evaluate anything else, and you can't have cyclic dependencies. Oh, right. The other part. We do not propagate errors. So if a component tries to be reevaluated and it fails, it'll be left in its last known state. So any component referencing that component will still like be referencing its last valid state. That means, for example, if your API key is coming from Vault and for whatever reason Vault breaks or Vault goes down, we're still using the last valid API key and metrics are still being sent. So like one thing breaking isn't going to make all your entire agent just stop working. But it also means like the declarative nature is a little maybe not completely true. It's more like, well, no, it's still true because the running component is still in its last valid state. It's just it can't update. So I guess it's still declarative. It's still being bound correctly. Matt?
For the exports, are we going to, is the pattern to have them, because we can essentially pass pointers around, that another component should not update anything in those exports and it's simply enforced by developer convention?
Yes. I think yeah, like maybe under really weird circumstances you might want to have a Go struct which expects to be overwritten. But that'll be up to the documentation of the type you're exposing. So okay. Like for like with the other example I was showing with like the metrics receiver and stuff, that's just an interface. So you can't really change that value, but it is expected that you do like mutations against it by like writing to the write-ahead log, right?
Mm-hmm. Yeah, I guess you could definitely see instances where you would add to a queue or some sort of data structure, for some sort of processing, but not override the data structure itself.
Yeah, like when we add a new type, we'll have to consider the ways people might interact with it incorrectly and document that as being invalid as at a convention level per type. Okay. So that's all that. I don't know if I want to dive in too much into the detail. I just kind of want to touch this at a high level about what's going on here. So I've opted for internal packages for this one, so we can kind of have like a little bit cleaner API at the top level than weird low level APIs at the low level. The top level flow package does very little. It just creates an update queue, a scheduler, and a loader, and then it wires those three things together. So when, for example, when the loader, it'll say like this component changed. If that gets called, we immediately put it in the queue. And then in a Go routine, while we're running the controller, we try dequeuing from that queue. And then if we get an element, we will reevaluate that thing and all of its dependencies. Otherwise, if like we just did a load, we have new components, we'll pass those over to the scheduler for running. So this is really just the glue code of all the underlying parts. I do want to show test components I wrote. Actually, no, hold on before I do that. So the root context, I copied all of the functions that Terraform was using, but then I changed the naming convention to snake case because I think these are more useful or more readable than like this, for example, which is what Terraform did. One exception, Terraform uses like an index function, which is different than CTY's index function. And I just didn't bring it over yet, but we'd want to probably match their implementation of it. And then I implemented one example function, whiwhich is env to get an environment variable. So I'll show you how that works. It's kind of gross. It's like a CTY function. So you have one parameter, which is the var name, and that takes a string. Then we output a string as response, and the implementation just like gets that value and then returns it back as a CTY value. We'd probably want to make these as minimal as possible because probably looking at this, you're like, oh, that's not very pretty. So it would be possible to have these like just as like a shim around like an actual function, kind of like how I'm doing it here with being a shim around the get env thing. Okay. I don't even know what half these functions do. I just imported the list. Like there's apparently you can do a CSV decode. That's interesting. We can look at these later, but I don't think there's. I mean, we can also take them out if there's something we don't want here. But I think most of these are probably pretty useful. Okay. And then the config file allows you to parse an HCL thing. Ignoring the implementation here, you get back this file, which really doesn't have anything at the moment. It's just like the name of the file, the raw HCL file, which you might need, and then the list of components to load. Okay. All right. I think, yeah, that's everything. So showing one of the tests, I'm using some tests here to like kind of just validate things end to end. So here's where my test components come into play. I have two of them. I have a tick test component, which will emit something on a frequency. It'll emit the current time on a frequency. So this will emit the current time every 1 second. And then I have a pass-through component, which any string is given as output will be re-given as output. So this is a really weird example, but every 1 second we're getting the current time, and then we're also, passing through hello world. And then here we pass through the ticker where like it, this will be reevaluated anytime the tick changes. So it'll reevaluate, it'll re-expose the current time every second. And then this will just, oh, right. And then this passes through what this is passing through. So it's like a chain. This should demonstrate that kind of the binding of values works across multiple components. And that's what I'm testing here. Right. The implementation of those is pretty simple. I'm registering them with the name and like, their types. I'm calling it pass-through config here. This should probably change. This should probably be changed to arguments, but for now it's just called config. And it doesn't do anything when it runs because like it's never gonna like do anything in the background. It just like anytime it gets updated, it'll pass through its current input as output. Then it's done. So this component is like really basic. That was kind of rambly. Did everyone understand what's going on here? Do you have any questions? Okay. Then the tick test component. This actually does do something in run. So it'll like wait for the next tick period, and then whenever it does that, it'll emit the current time at the tick frequency. So we call this just in case the frequency changes in between ticks. So when it updates, we'll store that new frequency and we reject it if it's 0. Oh, there's a bug here. The bug being here means that this isn't tested very well. Is that wrong? Oh. Yeah, that's not right. Ah, okay. So I guess this isn't being tested right now, and it needs to be. All right. What else I want to show? Showed the functions. Matt, you had something?
No.
Okay.
Sorry.
I don't know. I think I described all the various things here, like the component. I guess I'll generally say what's going on here. So when we create a component, we give it options for that component, which are like a shared logger, shared data directory, and then like shared function, the callback function. And then we give it like its initial HCL block. At this point, like we don't evaluate it because we don't know what it depends on yet. So when it needs to be evaluated, you can call this evaluate function, which will decode, from HCL into like the actual Go type. And then if we haven't built the actual component yet, this is the time to do it. Otherwise, we just update the existing one, and then we'll internally store arguments. So this exposes an interface to the controller where at any time the controller can ask, hey, what is your current like evaluated arguments? And we can return that. And this won't be updated if it fails, obviously. And then what is your current exports? So this will be updated anytime that component exposes new exports, which you can see happen here. So the component options, it's on state change. It points at our kind of set exports method, which will make sure that the export type hasn't changed, and then internally set it, and then inform the controller that, hey, this component just changed. You should queue us for processing. Oh, current health. Right. Okay. This is the last bit I think I'll probably go over since we're 40 minutes. Yeah. So there's a precedence here. We're tracking 2 internal health states for the component. We're tracking the health of the last call to evaluate, and then the health of running the actual component. So overall, like if the run exited, that is like the highest precedence on health status to show a user like, hey, it doesn't matter if this component is working or not. You should know like it's not even running right now. That's important. Then below that, if the evaluate failed, that's also really important to say to the user. But then below that, like if the component has its own health, we just give you that. But if it doesn't, we'll kind of fall back to whatever like the most recent health from either the run or evaluate method was. So that's all that like this is doing here. It's kind of heavily commented, but should be followable after kind of reading that precedence order. All right. And then I think I really, I'm not going to go into that. I think that should be enough for readers who want to like follow through. Like here's how we get the references of what a component's referencing, and here's the implementation of loader, which can apply a new set of HCL blocks into like what's being loaded, and give evaluate the graph and reevaluate a single component or whatever. Then the queue and scheduler and value cache. I think that's kind of all I want to describe. I do want to show that the value cache is actually really complicated. We have to like recursively build. So imagine like this HCL config file with like foo, something stream, bar, whatever. The expectation from like an HCL eval context is that you have something like this, where like you turn it into like a giant JSON object. So we do that recursively, and you can follow the implementation here for how that's being done. But it's probably like the most weirdly complicated part of all of the code. And we have a good test for it that kind of shows that that's actually happening underneath the hood. Yeah, so we expect, we can't just test one giant object because we have to have one variable per top level key, but this is showing that the constructed foo matches this CTY object, and the expected bar matches this CTY object. Also, that's shouldn't have the parentheses there. Okay, I'm not showing the DAG. I think most people here know what a graph is, and they can kind of follow the implementation. Nothing special is going on, and we showed everything else. Is there anything someone wants to look at, kind of, or do you kind of want to move to like discussion or any questions? Okay, thank you. Hopefully that was helpful.
Yeah, that was super awesome, and looking over it probably today and maybe write some components to see how things hook up.
Cool. Kind of embarrassing that the tick component's not being tested.
That's what you find when you do a public review, right?
Yeah.
Yeah. Does anybody have any questions about that, or just anything in general about the agent? Or any other topics people would like to discuss? All right. If no one has anything else, then yeah, we can give people back a little bit of time, and we'll meet again in roughly a month.
Bye,
All
everyone.
right. Thank you, everybody.
Bye.
Oh, bye.